we'll continue on in lesson 8.1. And there are different ways to do graphing for quadratic functions. I'm going to teach you today how to do it using a table. So in other words, we're going to pick some x values and then we're going to put it into the equations and get values for y. So one way to get the graph of a quadratic function is picking x values, but guess who's going to choose them for you? I am, because I know what x values are going to give you a good U-shaped graph that's either opening up or opening down, according to its a value. If I let you pick the x values, I already know which ones you would pick. You pick the nice ones like 0, and 1, 2, and 3 all the time, and you would not necessarily get the full picture of the U-shaped graph that you're going to get. So I'll be helping you pick your x values, and then we'll use them to find values for y. So we're going to be looking for the y values that will go with the x values that are chosen. So you can pick any value you want for x. Therefore, we say this is the domain of the quadratic function, because remember the x values make up the domain. So those x values and any other x value that we could have chosen will make up the domain. And since we can pick any value we want for x, because x in a quadratic function gets squared, it gets multiplied by a b value maybe. Can you square any number you want on the number line? Can the positive numbers be squared? Can they be taken times themselves? What do you think? Can all positive numbers be taken times themselves? Okay. Can 0 be taken times itself? Sure. How about negative numbers? Can they be multiplied by themselves? In fact, what happens when you take a negative number times itself? You'll end up with a positive number, won't you? Okay. So they're really, the domain basically means this. Are there any x values? What are the x values that you can use in the function? Well, we just decided we could use them all. So we're going to say the domain of any quadratic function is all real numbers. You're not going to have to think very hard when they ask you what is the domain of this quadratic function. You're going to get to say all real numbers. Okay? That's not going to be the thinking one. The thinking one is going to be the y one, because the y value is dependent upon what happens with the x values that you choose. So the y values make up the range. So therefore our range, when we have to identify that range like our goal says, when we have to identify the range, we know that we have this U-shaped graph. It either opens up or it opens down. And the y values are the up and down, aren't they? So if I have this graph that opens up, tell me something about it. Does it have a minimum or does it have a maximum y value? It has a maximum? Doesn't this one have a minimum? It doesn't go any lower than that point here down at the bottom where it turns. So it has a minimum y value? So it never goes any lower than that? How about when it opens down? It has a maximum and it never goes any higher than that. So can the range be all real numbers? What do you think? Do you think the range can be all real numbers? No. Because if you have this parabola opening up, it's going to get down to a certain y value and it's going to stop and turn and go back up. And it's never going to go any lower than that. Or if it's opening down, it's going to get to a y value and then it's going to stop and make a turn and come back down again. So we can't get any higher than that. So we can't say all real numbers for the range, ever, ever. You can never say all real numbers for the range. It'll either begin at the minimum or the maximum. So we're going to have to identify the minimum or the maximum of the quadratic function to help us be able to tell what the domain, or the range is, what the range is. Okay, and we'll practice that. So, use the given table. In other words, I chose x values for you to graph the function, and then we're to state the domain and range. Y equals 1/2 x squared is our function. Here it is right here, okay? Right there. So in our table, notice I have x values, And then we're going to substitute those in and get the y value that goes with it. So we have 1/2 is our, what value is that? A, B, or C?
A.
That's our A value. Should this, when we're all done graphing this, should our parabola be opening up or down? It's 1/2. If A is 1/2, it should be opening up when we're all done, right?
Yeah.
We're hoping for a U-shaped graph that is going to be opening up. Okay, we're going to put -4 in for the x. You have to put it in parentheses. You will get in trouble getting y values if you do not put your negatives in parentheses before you square them. Okay, so always use parentheses. So I'm using parentheses here to show the multiplication of that 1/2 out front and to show that I have a negative number here. Okay, and we're not going to try and do too much at once. What comes first, doing powers or multiplication? Do we take the 1/2 times the -4 first and then square it? Or do we square the -4 first and then multiply by 1/2? Isaac?
You have to square the -4 first.
Yeah, you're going to square that -4 first. So we're going to leave this as 1/2. And we're going to say, what is -4 times itself?
16.
16. So what are we going to get for our y value?
8.
8. 1/2 of 16 is 8. So let's write that ordered pair that we just found. We found ordered pair -4, 8. We just found ordered pair -4, 8. We have our first point for our graph. Okay, now you can either point by point, you can find it first and then go put it on your graph, or you can find them all and then go graph them all. Okay, let's just put that one on right away so that we have it. -4 and +8 for y. So go to your graph and graph that ordered pair -4, 8. Okay. Now we'll move on to doing the next x value chosen for us, and that is -2. So we'll substitute -2 in for our x value. In this one, we just have the ax squared term. It's actually pretty easy. We don't have quite as much substituting to do. What do I do first? Parentheses, square that -2, right? What is -2 times itself? 4. So we have 1/2 times 4 now. What is 1/2 of 4? 2. So we just found another point on our graph, ordered pair -2 for x, +2 for y. So now we'll go put that one over on our graph, -2, +2. Okay. Can we move on to 0? Anybody have any questions? Okay, then let's move on and do 0. 0 squared is? 0, so we have 1/2 times 0. 1/2 times 0, or 1/2 of 0 is still? 0. Yeah, that's 0. So we have ordered pair 0, 0. Both x and y are 0 this time. So that's right at the origin. I'm feeling pretty good. I'm starting to see my part of my U. And it's looking like it's going to open up. Do you think we just found the turning point, or maybe not yet? What do you think?
Yes.
We might have found the turning point? Okay. So let's go on to doing +2 now. 1/2 times +2, that's going to get squared. +2 squared is 4. And 1/2 of 4 is 2. So we have ordered pair 2, 2. And so we'll go put that one on our graph. I think the green one was the turning point. And our last one is +4. 1/2 of 16. Half of 16 is 8. And we just found ordered pair for 8. So we're ready to go put that one on the graph. What did I say in yesterday's notes about quadratic functions? What does every quadratic function have with regard to that turning point called a vertex? What's going to happen every time on either side of the vertex? What's going to happen? Starts with an S, right?
Symmetry.
Symmetry. Is there any symmetry going on here?
Yes.
There is. This point is a reflection of that one, or vice versa. They're symmetric. They're on equal distance from the green one. They're both 2 away from the green, and at the same y height. Those are symmetric points. The ones that I have in black up here are symmetric points. What's the only point that'll never have another point symmetric to it? In this case, it's ordered pair what? 0, 0. But will it always be that? Not necessarily. What's that point called right now? What's that point called, that turning point? Whether it's up or it's down, what's that point called? Vertex. That's the vertex. The vertex will never have a point symmetric to it because it's the place where it stops and there's no other point that shares the same y value. It turns there. It either turns and goes back up or it turns and goes down. So the only one that won't. So that's why I also pick x values for you because I like you to be able to see the symmetry. So what we do now is we don't take a ruler and we don't connect these with line segments. We do a nice smooth curve. So however it works for you, you start and you draw this curve that will give you a U-shaped graph. And sometimes it'll look kind of V-ish, but we don't want to use any straight edges that would make it look like a V. It sometimes just might appear like one, but we try and make it as U-shaped as you can. Okay? It's a nice, smooth U-shaped curve called a... No, what's the curve called? What's the graph called?
Parabola.
Yeah, I said you're going to want to say parabola, but it's parabola. It's a parabola, yeah. And we said our parabola should open up. Do we do well?
Yes.
Yeah, we're feeling pretty good about it. Okay. So any questions on that before we move on to identifying its domain range? Okay, what's the domain of this function? Just those x values I chose for you? Is the domain just -4, -2, 0, 2, and 4? Look up above. What does it say about the domain of a quadratic function? It will all real numbers. Remember, that's the non-thinking one. It's always going to be all real numbers. But I could have chosen any x value I wanted. It's just that I chose those because I knew they would give you a good picture of the graph. So the domain is all real numbers. And remember the abbreviation for that, because I already know there's some people in here who will be like, do I have to write all that out, or can I write ARN? No, you can't write ARN. No arms. You can do this. That's what you can do for all real numbers. Okay? Now, the range. Is the range all real numbers? In other words, are there, for points on here, can you have any y value you want? Any points on that curve going to have a y value of -5? No. You sure? What's the lowest y value any point on that curve is going to have? 0. Remember, this one has a minimum or a maximum. What is this one? Minimum. Let's write that right on our graph, okay? We have a minimum, and the minimum is always, or maximum, is always the y value of the vertex. So what's our minimum? The minimum is 0. So when you do the range, here's what you're going to say. When you have a minimum, you're going to say it can be that number and anything larger than that, right? Higher than that, right? So we're going to write that as an inequality. Y is greater than or equal to 0. It can be 0, or it can be any number larger than 0. All those other points on that curve have y values of more than 0. The vertex, the lowest point, has a y value of 0. So when you write the range, it will always be an inequality. So y, in this case, this was a minimum, so we say it can't go any lower than 0, and it can only go up from there. Does that make sense? What's the range, will the range ever be all real numbers? What do you think? No, it's always got to stop and turn. It's always going to hit a minimum, or it's always going to hit a maximum. Okay? Okay, let's go to the back and see what we got back there to do. It says, use the given table to graph the function, then state the domain and the range. So it looks like we get to do one more together here before we call it quits. Because we need just a little more practice. Okay, this one's got more x values because apparently if I only do 5 of them, they get too close together and it'll give you just this tiny little u. So let's start with -3. Oh, be really careful. That's a subtraction, that's a negative sign. It does not replace the negative of the x value. It says negative, or the opposite of the x squared. So that always comes along. Negative. Then we put in parentheses our x value, which in this case is -3 to start with. That's going to get squared. Plus 1. So that negative sign does not take the place of the negative on the -3. It's separate from the x squared, it's out front. So now what we're going to do is we're going to say that negative sign is still going to come along. That negative sign that was out front is still going to come along. What is -3 squared?
9.
9. So in reality, what this is saying is this. What's the opposite of 9?
-9.
-9. We have -9 plus 1. That's what that is. That's an opposite of sign. We got 9 when we squared -3. So it says the opposite of 9. The opposite of 9 is -9. And -9 plus 1 is?
-8.
-8. So what's our ordered pair this time? What's our ordered pair? -3, -8. So go ahead and go to your graph and put it on. Count carefully while you're graphing these so you get a good representation of your point, yes.
Wouldn't it be easier if there's a negative in front of the x if we multiply -1 to -3 first?
No, you can't because you don't multiply before you do powers. You always do powers first, but that negative sign is like multiplying by a -1, you're right. So that might be a good idea for some of us to do. Make this negative sign into a -1. -1, -1, and then -1 times 9 is -9. Maybe that'll make better sense to you. But we don't multiply just like in the last one. We didn't multiply it by the half first. We squared the x first. So I like that idea of treating that as a -1. I think that might be more user-friendly for you guys. Okay? So we're going to treat that negative sign as a -1. Okay? So -1 times -2 squared, add 1. So we square first before we multiply by -1. So that's going to be a +4. -1 times 4 is? -4. Or the opposite of 4 is -4 plus 1.
-3.
And we get a y value of -3 this time. So -2, -3. And then you can go graph that one. Okay, and then you can just go ahead and just keep filling out that table, and I'll do it up here if you need to do a glance up quick to see if you're doing it right. So mine are out there just for you to check your work with, okay? You wanna try and do it so that you can do it when in your homework. And if you're doing it right, you should start to see some symmetry happening. All of a sudden, some x values will get back, they'll get the same y value that you got back for a different one. And this time our a value is positive or negative? What is our a value this time? Negative 1, isn't it? Yeah. So should it open up or should it open down? It should open down. Should it have maximum or minimum? A maximum, okay. So after you get all of your points graphed, you should have a nice U opening upside down. I'm just going to scroll a little bit here so I can draw my U with arrows at both ends. And then I'm going to say to myself, while I'm at it, before I start doing my domain and range, I'm going to say this one has a maximum. Which means the y value will never get any higher than that, right? What is our maximum? Maximum is 1. So we have a maximum of 1, which then should help us identify the range, right? What's the domain? All real numbers. The not making part. No, all real numbers. Okay, so you can write your abbreviation or you can write the word all real numbers. Okay, and then, so I'm just going to do the abbreviation. What's the range? What's the range for this one? Yeah, y is less than or equal to 1. Y is less than or equal to 1. In other words, it can't go any higher than 1. It has to be 1 or less than 1. It has to be in that. So when you have a maximum, you just kind of start to see a pattern that's going on. Okay? So anybody have any of these that you need me to go back for you to see or have any questions? Took the whole time with me trying to also reinforce what we learned for today. No questions? Nobody needs me to show anything back? Okay, then let me get, why don't you get out a sheet of loose leaf paper that you will write down what the assignment you have is. We have a lot of problems there, Fran. Okay. So we have, let's see. Okay, but not all of them, I don't think you have to grab though, possibly. Let me double check here and see.
4 of them you do.
4 of them you do? Okay, so you're only graphing 4. So, we can do all of this homework, it's only 4 we're graphing. So using yesterday's notes and today, you should be able to do this homework that is written over there on the board. So Make sure that you've written the assignment down carefully, Rose. Sure, I can write it.
Sorry, I'm coming.
Don't forget your phone.
And I think you arranged the time for which part? So we work tomorrow or after school?
First school tomorrow?
Yeah.
Riley, you gotta come in either tonight at school or tomorrow or first school then. Okay, I'm doing that right now. Unless you want, I'm not, I'm not, my lunchtime, sorry. So, tonight after school or tomorrow morning before? Okay. Rose, did you get your papers down?
Can you go down?
Sure. Like this, so you can see that?
So everybody had some other sections.
Yeah, I think I got it. Thank you. He's probably still out there. Rose, will you yell at Josh about his phone, please?
Should I give you?
Yeah, you can if you think, because he should just be right around the corner out here.
Did you get it all copied?
Yeah. Oh, you got the golden notes? I got that.
I'm sorry, there's a bag.
Well, right now, yeah, it's not one. Oh,